Hello students, welcome to Shri classes. Let us continue polynomials, lecture number 3. Last time we discussed about forming of a quadratic polynomial when the sum and product of zeros is given. Under the same category, a little more complicated numericals will be there. Thing is, we may have to form the quadratic polynomial from the sum and product of zeros of the given polynomial. But thing is, for a new polynomial, new sets of zeros will be given, and those values you have to find out, and the new polynomial is to be found out. One example I will take you to illustrate that one, and the example goes like this. One example, first numerical. You can go on putting the serial numbers. I am taking from RDS. If alpha plus beta equals 24 and alpha minus beta equals 8, find a quadratic polynomial. Find a quadratic polynomial. How do you find out over here? Given alpha plus beta equals 24, alpha minus beta equals 8. By addition, you get 2 alpha is equal to 32, and therefore alpha is equal to 16 here. Substitute in one of these values to get beta. Now alpha minus beta equals 8, so beta equals alpha minus 8, 16 minus 8, which is 8. Therefore we have got beta equals 8 here. So how do you form the quadratic polynomial? Let p of x be a quadratic polynomial. Which is given by p of x equals k times, k is a non-zero constant, you have to consider all the time, okay, x square minus alpha plus beta times x plus alpha into beta. This is a quadratic polynomial. K times x square minus alpha plus beta. Alpha is 16, beta is 8, so alpha plus beta is 16 plus 8 times x plus alpha into beta is 16 into 8. Therefore k x square minus 32x plus 4. So this is the quadratic polynomial which we have found out. Interesting. This question was a little bit different. 16 plus 8, 24 plus. It is correct. 24. Please correct this. 16 plus 8, 24. And I think 120. It's correct. So thing is, this is a little different. Sum and product of zeros are the relationship between zeros is given in this way, and we have to find out the zeros and then take out the sum of zeros and product of zeros. So note it down. Then we will go to the second problem. Here we will take another question. If alpha and beta are the zeros of this polynomial x square minus 1, then find a new polynomial. We have to find out one more polynomial, new polynomial, whose zeros are 2 alpha by beta and 2 beta by alpha. Here these are the zeros of a new polynomial. So what is that name I can give for these things? I can give these things as alpha dash is equal to this one and beta dash equals this one. I can give like that, isn't it? Alpha dash and beta dash, and try to find out alpha dash plus beta dash, alpha dash into beta dash. If I know those things, then I can form a new polynomial. The name could be g of x, isn't it? But in order to find out alpha dash plus beta dash or alpha dash into beta dash, I must know the values of alpha and beta, for which this equation helps us. You understand? So let's see here. X square minus 1 solution. F of x equals x square minus 1, it is given to you. How do you find out the zeros of this one? You can find out the zeros by subjecting it to 0. So to find zeros, or you know already, to find zeros you have to subject it to 0. Let f of x equals 0, x square minus 1 equals 0, x plus 1 into x minus 1 equals 0, x plus 1 equals 0, x minus 1 equals 0. So x equals minus 1, x equals plus 1. So alpha is minus 1 and beta is plus 1. You got it? These are, tag this as 1 here. Both roots put together, I am tagging this as 1 here. Alpha is minus 1, beta is plus 1. Now it is very easy to find out this one. 2 alpha plus this thing. I will say now. Let the zeros of new polynomial b let the zeros of new polynomial b alpha dash equals 2 alpha by beta, which is given to us, which is equal to, substitute the values here. 2 times alpha is minus 1 divided by beta is plus 1, which equals minus 2. And next is beta dash equals 2 beta by alpha, which equals 2 times 1 divided by alpha is minus 1, which is minus 2. Understood? Therefore, sum of zeros alpha dash plus beta dash equals minus 2 minus 2 minus 4, and product of zeros alpha dash into beta dash equals minus 2 into minus 2, which is plus 4. Plus 4. Is it right? And 2 beta by alpha, 2 alpha by beta, correct. And therefore new polynomial is given by g of x equals k times x square minus alpha dash plus beta dash times x plus alpha dash into beta dash, which equals k x square minus alpha dash plus beta dash is minus 4 plus alpha dash into beta dash is 4 equals k times x square plus 4x plus 4. This is the answer, this, isn't it? So this is how we formed. Now the same method, the same numerical, a little bit with a different way. One more method is important. Why it is important is, here x square minus 1 is a given polynomial. We were able to split the middle term. Rather than splitting the middle term, I could say we were able to factorize this one and get the values of alpha and beta. But sometimes you will be given such a quadratic equation or a quadratic polynomial, and it becomes equation when you subject it to 0. Such a quadratic equation where the splitting up of the middle term is not at all possible. In that case, you cannot find out the alpha and beta values, isn't it? So in that situation, what is to be done? Very briefly, I will explain. First, you note it down. I hope you have noted down. Let me find out another method. Remember this answer, x square plus 4x plus 4 we have got. This is a new polynomial, and I am adopting method 2 for this. Why to adopt that method 2? Whenever we are not able to find out the factors by splitting the middle term or by factorization. If I am not able to find out the alpha and beta, that is roots, by splitting the middle term, then we have to follow other method. See the other method how it is. And this other method which I discuss, most of the toppers follow this method. Most of the toppers, who have a practice of solving, having solved many numericals, they will never go to this the way we did here. They may follow this method. See here, let alpha dash and beta dash be the new this thing. Okay, let's find out once again a solution. F of x equals x square minus 1, a equals 1, b equals 0, c equals minus 1, and let alpha dash and beta dash be zeros of what? G of x, which is a polynomial. Therefore alpha dash plus beta dash equals, I'll write of these values also. Let alpha dash and beta dash be the zeros of g of x. Therefore alpha dash equals 2 alpha beta and beta dash equals 2 beta by alpha. Now sum of zeros, alpha dash plus beta dash. Before that, I think here I will find out. Just a moment. Let me do once again a little bit different way. Let me discuss this a little bit different way once again. Here, let's see here. Solution. F of x equals x square minus 1, a equals 1, b equals 0, c equals minus 1. Therefore alpha plus beta equals minus b by a, which is 0 by minus 0 by 1, which is 0. Alpha into beta equals c by a minus 1 by 1, which is minus 1. Mark this as 1 and this as 2. Is it clear? Now let alpha dash and beta dash be new roots of g of x. Directly I'll write of polynomial g of x. Given alpha dash equals, what is that is given? 2 alpha divided by beta, and beta dash equals 2 beta by alpha. So this is given to you. Okay, now I'll work out sum of zeros and product of zeros. If I work out sum of zeros and product of zeros, my job is done. So here also one more step I can do here. Alpha dash plus beta dash equals 2 alpha by beta plus 2 beta by alpha, which equals alpha into beta is the LCM here. So beta cancels. If I multiply this one, it's beta cancels alpha, 2 alpha square plus 2 beta square. I have taken the LCM here. Here beta cancels alpha square, alpha cancels beta square. Okay, this is what we are getting. Therefore alpha dash plus beta dash equals 2 times alpha square plus beta square, the whole divided by alpha into beta. Therefore alpha dash plus beta dash equals, what is the value of alpha square plus beta square? How do you get alpha square plus beta square? I must express the numerator in terms of alpha plus beta. Denominator I have already alpha into beta, the value of which I know. If I express alpha square plus beta square in terms of alpha plus beta, then I'll be able to get that one. How do you do that one? Alpha plus beta square equals alpha square plus beta square plus 2 alpha into beta. Therefore this is equal to alpha square plus beta square is equal to alpha plus beta whole square minus 2 times alpha beta. So the value of this is alpha plus beta the whole square minus 2 times alpha into beta. This value I know here, and this value I know here. I'll substitute the 0 and this in this value and get the value here. So what I do here, I hope you have understood here. See, 2 times into bracket alpha plus beta the whole square minus 2 times alpha beta, the whole divided by alpha into beta. Substitute the values. 2 times into bracket 0 the whole square minus 2 times alpha into beta is minus 1, the whole divided by minus 1. So 2 into bracket minus of minus 2 divided by minus 1, which equals minus 4. So you have got alpha dash plus beta dash equals minus 4. 1. This is 3 here, mark it. And now I'll take up product of zeros. Alpha dash into beta dash equals 2 alpha by beta into 2 beta divided by alpha, which is nothing but 4 here. Alpha cancels, beta cancels, 4 here. And therefore, g of x equals k times x square minus alpha dash plus beta dash times x plus alpha into beta, alpha dash into beta dash. Therefore, g of x equals k times into bracket x square minus alpha dash plus beta dash is minus 4x plus 4, which equals k times x square plus 4x plus 4. I hope you have understood. This is how we can solve it. Understood? So this is quite interesting here. What I explained, I just want to tell you here. I found out from the given equation sum of zeros and product of zeros, and assigned the values of alpha dash and beta dash for new types of zeros which are given, and find out the sum of new zeros, alpha dash plus beta dash. And in order to find out this value, entire expression I converted in the form of alpha plus beta and alpha into beta. Check here. Finally, alpha dash plus beta dash is equal to, entire equation has got only 2 times in terms of sum of zeros and product of zeros, which I could find out from the given equation, and substitute and get the values of new sum of zeros. Similarly, alpha dash into beta dash, which is the product of new zeros, if I multiply this, I'll get this value, and g of x is the new polynomial. After substituting the values of sum of new zeros and product of new zeros, I get the value of a given polynomial, which is a new polynomial, isn't it? So this method, you should learn this. Believe me, sometimes this equation f of x is equal to x square minus 1, such equations will never be given to you. If at all the new zeros are given, and if you have to form a new quadratic polynomial, then definitely the given polynomial, for the given polynomial, you will not be able to factorize and find out alpha and beta. In that case, you have to find out alpha plus beta, alpha into beta, and the new sum of zeros, new product of zeros must be expressed in terms of sum of zeros and product of zeros of the given polynomial, and then you can form the new polynomial. Very interesting. Make sure that you know this process very thoroughly. All of you should know this method, how to solve this. Okay, fine. So note it down. One more very interesting problem here. Given f of x is x square minus 3x minus 2, we have to find a polynomial whose zeros are this and this. So whose zeros are these two means, can I assign these two as alpha dash and beta dash? I can do that one. Find out the sum of new zeros, product of new zeros from the existing one, and then you can find the new polynomial g of x. So let us see here, very interesting solution. F of x equals x square minus 3x minus 2. If you can find out alpha and beta, the roots, then it is very easy to substitute here and get the value of alpha dash and beta dash. So let me try to find out the roots of this equation by splitting the middle term. So 2 into 1 minus 2. Here I require minus 3. Minus 2 into minus 1. It will be minus 3, but this will not be minus, this becomes plus. Not possible. So 3 into 1, 3 into 1, not possible. You cannot split this middle term, isn't it? So what will you do now? If you want to find out alpha and beta, the roots of this one, we have to split by the middle term. But can you split the middle term here? It is not possible. If you get questions like this, there is no other go other than expressing the given roots in terms of here alpha dash and beta dash. You must be able to express in sum of zeros and product of zeros. So let's see. A equals 1, B equals minus 3, C equals minus 2, alpha plus beta equals minus B by A, minus of minus 3 divided by 1, which is 3. Alpha into beta equals C by A, which is minus 2 by 1, which is minus 2. You have got sum of zeros and product of zeros. Mark this as 1, mark this as 2. Let for, or let a new polynomial be g of x and new roots be alpha dash equals given 1 divided by 2 alpha plus beta and beta dash equals 1 divided by 2 beta plus alpha. So first find out sum of zeros and product of zeros. Let us see how to find out now. Sum of zeros. Now alpha dash plus beta dash equals 1 by 2 alpha plus beta, 1 divided by 2 alpha plus beta plus 1 divided by 2 beta plus alpha, 1 divided by 2 beta plus alpha. Therefore alpha dash plus beta dash equals, take LCM, 2 alpha plus beta, 2 beta plus alpha. This will cancel, 2 beta plus alpha plus this will cancel, 2 alpha plus beta, which equals 2 beta, here it is 3 alpha plus 3 beta, the whole divided by I have to multiply this entire thing over here, then only you will get it. So first step I'll write as it is here, 2 alpha plus beta into 2 beta plus alpha. Okay, fine. Therefore alpha dash plus beta dash equals 3 times alpha plus beta. Good. Numerator at least I got in terms of alpha plus beta, value of which is known to be 3 here. Now denominator also I should express in such a way that I must be able to get the denominator expression in the form of alpha plus beta and into alpha into beta, then only it's possible. So let us multiply 2 alpha into 2 beta, 4 alpha beta, plus 2 alpha into 2 beta is over 2 alpha into this one, 2 alpha square, plus beta into 2 beta square, plus beta into alpha into beta is nothing but like this. Okay, so here alpha dash plus beta dash equals 3 times alpha plus beta, the whole divided by, let me check, this is 2 alpha into 2 beta is 4 alpha beta, 2 alpha into alpha is 2 alpha square, beta into 2 beta is 2 beta square, and beta into alpha is alpha beta. Correct. This is 4 alpha beta plus alpha beta, 5 alpha beta, and here I'll take common here, 2 times alpha square plus beta square plus 5 times alpha into beta. Now alpha square beta square I do not have, but I should obtain alpha square plus beta square. Since last 2 examples you already know that this value is nothing but alpha plus beta the whole square minus 2 times alpha into beta. So this equals 3 times alpha plus beta the whole divided by 2 times into bracket alpha plus beta the whole square minus 2 alpha beta, okay, plus 5 alpha beta. Okay, now you substitute the values. This is, you understood how did I get this one? Alpha square plus beta square is alpha plus beta the whole square minus 2 times alpha into beta. Okay, that's fine. Now 3 times alpha plus beta is 3 the whole divided by 2 times alpha plus beta the whole square, 3 the whole square minus 2 times alpha into beta, which is minus 2, okay, and plus 5 times minus 2, which equals 3 3s are 9 here. This I will evaluate, 2 times 3 3s are 9, minus of minus plus 4 minus 10. So this is 26 minus 10, which is 16. So this will be 16 here. So we are getting alpha dash plus beta dash as 9 by 16 here. Oh my god, we got alpha dash plus beta dash as, therefore alpha dash plus beta dash equals 9 by 16. What is this equation? 1, 2, 3 here. Now you have to find out alpha dash into beta dash. Next is alpha dash into beta dash. So 1, 2, this is 3. So where should I do this? Let me see. I'll try to do here and finally try to form the quadratic polynomial at this space available here. Okay, this is this space. I'll keep it for quadratic polynomial. Or you can understand if I do here, let's see. Okay, at the bottom here I need to find out alpha dash into beta dash. Alpha dash into beta dash equals 1 divided by 2 alpha plus beta into 1 divided by 2 beta plus alpha. You got it? Which equals, dear students, see here, I am taking the denominator. What is the denominator? 2 alpha plus beta into 2 beta plus alpha, isn't it? So this denominator value, wherever I am getting this value, this 16 is the denominator's value. So it is this denominator's value here. Are you able to understand? Is it not 2 alpha? This is the product here. So it is nothing but 1 divided by 2 alpha plus beta into 2 beta plus alpha. I have already worked out over here. This I have worked out. And finally, I got the denominator as 16 here. And therefore, I'll write 1 by 16. And therefore, alpha dash into beta dash equals 1 by 16. This is 4 here. I hope you have understood. Got it now? Alpha dash into beta dash is 1 by 16. So, can we form the quadratic polynomial now? I'll form here, this side. And therefore, see, here I'll form g of x is equal to quadratic polynomial finally k times x square minus alpha dash plus beta dash into x plus alpha dash into beta dash. This is the quadratic polynomial which equals k times x square minus alpha dash plus beta dash is 9 by 16 here. 9 by 16 times x plus alpha dash into beta dash is 1 by 16. You can end the polynomial here, but as the 16 is there in the denominator, let me take the LCM here. So k by 16 16x square minus 9x plus 1. This is the quadratic polynomial. So let us check the answer for the third question. This is R.D. Sharma 18th question. 18th question. Just a moment. Let me check the answer for 18th question. This is the 18th question. K times x square minus 9 by 16x plus 1 by 16. Perfect. So I hope you are understanding this problem, how to solve here. Dear students, very important, such questions have appeared in the previous years. Only thing is, unfortunately, we are not able to split the middle term and find out alpha and beta over here. If we can find out alpha and beta, then definitely directly you can substitute here and new alpha dash, new beta dash can be found out, and directly we can substitute in this polynomial over here. It is possible. But whenever it is not possible to split the middle term and find out the zeros, this entire process is to be found out. Okay, I hope you are understanding, and let me take few more numericals. Let us start type 3 numericals. To find the values of expressions containing alpha and beta. This is also one of the important typical type wherein lot of manipulation skills are required. I request all of you to watch very carefully and note down and practice yourself. Otherwise these numericals should be very difficult to solve. Okay, now dear students, I hope you understand the complexity of these things, even previous couple of problems. But you know, everyone can do that. A little practice is required, some effort is required. So my request would be to see that you put good efforts in solving these things yourself, so that you will be able to solve this. Now here let me try to find out alpha and beta for this. Alpha and beta, the zeros, by splitting the middle term. Let me try here. So x square minus 2x plus 3 equals 0. I require 3 here, 3 into 1, 3. I require, but I should split in such a way that I should get minus 2. Tell me how to split it. The factors of 3 are 3 and 1. Do you find any other factors? No. So these 3 and 1, here I should get plus here. If it is minus and minus, I'll get plus. But here, this is not minus 2. This is becoming minus 4 here. So is it possible to split the middle term for this and find out alpha and beta for this? Same case of last numerical. It is not possible. Or you try with any other things. I should get the product 3 here, but here I should get minus 2 here. If the product is to be 3, factors of 3 are only this 3 and 1. And with this 3 and 1, can you get minus 2 over here? But I should get plus here. Minus 3 plus 1 equals minus 2, but the product is minus 3 here. Isn't it? And therefore, it is not possible to split the middle term and find out the roots of this equation. Now, for this equation, what is that we have to find out? I have to find out a series of questions here. And how to find out? Let us see here. First, let me find out the sum of zeros and product of zeros and keep it ready. And then I list the questions here, a series of questions, and we'll try to solve that one. Okay. Let's see here. First, find out alpha plus beta, sum of zeros. A equals 1, B equals minus 2, C equals 3 here. And alpha plus beta equals minus B by A, minus of minus 2 divided by 1, which is 2. And alpha into beta equals C by A, which is 3 divided by 1, which is 3. Mark this as 1 and mark this as 2. Now this I have found out, and let me start finding out the different numericals now. First thing, find alpha square plus beta square. I'll begin with this. Yeah, tell me, how do you find out? Do you know the values of alpha and beta? No, I don't have the values of alpha and beta. Had I known the values of alpha beta, substitute here and get this value. So this expression must be expressed in terms of sum of zeros and product of zeros. How do you do that one? Here we know alpha plus beta, the expansion contains alpha square plus beta square plus 2 times alpha beta here. This is the expansion. What is that we want? This is what we want here. And therefore alpha square plus beta square equals alpha plus beta the whole square minus 2 times alpha beta. Transpose it, which equals, what is sum of zeros? Plus 2 the whole bracket square minus 2 times alpha into beta, 3 here. So therefore this is 4 minus 6, which is minus 2. 2 2s are 4 and 2 3s are 6, minus 6 minus 2. Therefore alpha square plus beta square equals minus 2 here. Important, how to manipulate in order to get alpha square plus beta square. How to manipulate the algebraic identities is very important now. First question is over. So you know, if you are asked alpha square plus beta square, how to get alpha square and beta square in terms of alpha plus beta and alpha into beta. This is important. All these things I will be marking under blocks. Second question. Second, find 1 by alpha plus 1 by beta. Do you know the value of alpha and beta? No. I know sum of zeros, product of zeros. Express this one in terms of sum of zeros and product of zeros, which equals, see here, alpha into beta, beta plus alpha, which is alpha plus beta divided by alpha into beta, and which equals sum of zeros is 2 here and product of zeros is 3 here. You got it. So 1 by alpha plus 1 by beta equals alpha plus beta into alpha into beta. Mark this. This is what we came to know. Third one. Let me take something this. 1 by alpha minus 1 by beta. Minus 1 by beta. I think this is still complicated. I don't know how to find out this. Let's see. Now, alpha into beta, beta minus alpha. You understood? Beta minus alpha here. So what to do? beta minus alpha, from where should we get the value of beta minus alpha here? See, beta minus alpha the whole square equals beta square plus alpha square minus 2 times alpha into beta. Is it correct? Beta minus alpha square is beta square plus alpha square minus 2 times alpha into beta expansion. What is this? You know already, which is nothing but this is alpha square plus beta square, alpha plus beta the whole square minus 2 alpha beta minus 2 alpha into beta. So remove this bracket now. Alpha plus beta the whole square minus 2 alpha beta minus 2 alpha into beta. Therefore alpha plus beta the whole square minus 4 times alpha beta. This is beta minus alpha the whole square. But we want beta minus alpha here, which equals plus or minus under root of alpha plus beta the whole square minus 4 times alpha into beta. Are you able to understand? And therefore, what is that I have to substitute instead of beta minus alpha? Instead of beta minus alpha, I am substituting this value over here. This is coming over here. Why it is so? I know alpha plus beta and alpha into beta. So if I substitute under root these values, I am going to get over here, isn't it? And therefore, let me check now. So you have understood here how to obtain beta minus alpha, isn't it? Now one more question to you. Let me pause here a little bit. What about alpha minus beta the whole square? Is it going to be a change here? Even if it is alpha minus beta the whole square, it is alpha square plus beta square minus 2 times alpha beta. The expansion, see dear students, so interesting. Whether it is a minus b the expansion, a minus b the whole square or b minus the whole square, the expansion is same there. Are you able to understand? So beta minus alpha the whole square or alpha minus beta the whole square, the expansion is same. And finally, what about this value? This value, whether it is beta minus alpha or it is alpha minus beta, equals under plus or minus under root of alpha plus beta the whole square minus 4 times alpha beta. Is it not interesting? Yeah. Now you have understood how to put this value here. So what I will do here, substitute this value here and try to find out. Therefore 1 by alpha minus 1 by beta equals plus or minus under root of alpha plus beta the whole square minus 4 times alpha beta the whole divided by alpha into beta. What toppers do? All these things they write it and by heart it as identities. थोड़ा अक्ल चलाना पड़ता है, but many things you can by heart and remember this. It is possible. So let me find out the values here. Therefore plus or minus under root of, what is the value of alpha plus beta? 2 square 4 minus 4 times alpha into beta 3 here minus 4 times 12 the whole divided by alpha into beta 12 over here, isn't it? And therefore here what is not possible here? We cannot have a negative plus or minus. Alpha plus beta is 2 here 4 and alpha into beta 3. 4 3s are 12. Is it minus 3 or plus 3? Plus 3 here, isn't it? Therefore we get here under root of minus 8 divided by 12, but here under root of minus 8 is not defined. Therefore finally I say 1 by alpha minus 1 by beta is not defined. I hope you have understood. Alpha plus beta the whole square minus 4 times alpha beta. Students, a small mistake. Alpha and beta is not 12 here, 3 it is. Okay, it is not 12, it is 3 here. Okay, fine. Now you may ask, why did you find out this one? See, in this equation, for this given polynomial, I could not find the value of alpha minus beta, but I will take probably you may find out another problem where you will be able to find the root of this value, and if you can find out the root of that value, once you have to take plus, once you have to take minus and find out the values. Are you able to understand? The main logic what is that you have to understand over here is how to express beta minus alpha, how to calculate beta minus alpha or alpha minus beta in terms of sum of zeros and product of zeros. That is most important. Anyway, for me in this case, this value is not defined. Why not defined? What is under root of negative number? You have studied already in quadratic equations. That is, if the discriminant is 0, then the real roots do not exist, isn't it? And therefore here also for this value I have ended up with minus of under root of minus 8, which is not defined. Okay, it's a complex number, it is not a real number, and therefore I'll say this is not defined in this case. So I have found out alpha square plus beta square, 1 by alpha plus 1 by beta. Third one is this one. Next, fourth one I'll take. Please note it down. Let me take a few more such questions. 1 by alpha plus 1 by beta minus 2 times alpha into beta. 1 by alpha plus 1 by beta minus 2 alpha beta, minus 2 alpha beta. What is the question? This is the equation given to you, and you have to find out the value of this expression. Therefore, to find the values of expressions containing alpha and beta. So how do you find out the value of here? Do you know alpha and beta value? No, I know only in terms of sum and product of zeros. So I have to convert this entire expression in terms of sum of zeros and product of zeros. Therefore, this equals, take here, what is the LCM here? Alpha into beta, and this is beta plus alpha minus 2 alpha into beta. Therefore, this is simple. What is beta plus alpha is nothing but alpha plus beta, the whole divided by alpha into beta minus 2 times alpha beta, which equals, this much is enough, or you can take LCM also. Even if I take LCM, I will be able to find out the values. Alpha into beta, this is alpha plus beta, put it into bracket because I need to substitute the values here, minus this is 1 alpha into beta times 2 alpha into beta, the whole square, which equals, what is the value of alpha plus beta? 2 here, 2 minus 2 times alpha into beta 3, the whole square, the whole divided by alpha into beta 3 here, which equals 2 times 3 3s are 9 into 2 minus 18 divided by 3, which is minus 16 divided by 3 here. Is it clear? 2 minus 3 3s are 9, 2s are 18, minus 18 divided by 3 here, minus 18, okay, that's right, minus 16 by 3. This is what I have got, 1 by alpha plus 1 by beta as the value here. Fifth one, another couple of things I'll take. Alpha square beta plus beta square alpha. You got it? Beta square alpha, or alpha square beta plus alpha beta square. This also we can write. So how do you express this in terms of sum of zeros and product of zeros? Think of, would you be able to do that? See, this equals, what is common out of this one? Alpha beta is common here, so left here is alpha plus beta. Is it correct? Therefore put the values down. Alpha into beta 3, alpha plus beta 2, which equals 6. Sixth one, let me take one more. Alpha square plus beta, alpha to the power 4 plus beta to the power 4. I don't know what is to be done now. Alpha to the power 4 plus beta to the power 4. So let us see some manipulation we have to do. See here, alpha plus beta, the whole square equals alpha square plus beta square plus 2 alpha into beta. Therefore, alpha square plus beta square equals minus 2 alpha beta. But what we want is alpha to the power 4 plus beta to the power 4. So from where do you find out that? See, alpha square plus beta square, the whole bracket square equals alpha to the power 4 plus beta to the power 4 plus 2 times alpha square into beta square. And this is what we want. Alpha to the power 4 plus beta to the power 4 equals alpha square plus beta square, the whole bracket square, minus 2 alpha beta, the whole square. Alpha square into beta square is this one. So finally I have ended up with this one, okay, the expression. But I know alpha square plus beta square, the whole bracket square, this alpha square plus beta square equals alpha plus beta the whole square minus 2 alpha beta the whole square. So therefore here this is the final, this is not the final, I'll just erase this one. Now let me write based on this modification, alpha 4 plus beta to the power 4 equals, how do we write this alpha square plus beta square? Alpha plus beta the whole square minus 2 alpha beta the whole square minus 2 alpha beta the whole square. So this is the expression. I hope you have understood. How did I get this one? You know all this sequence what I have done here. So finally, how do we get this value? Substitute here, which equals alpha plus beta 2 the whole square, which is 4, minus 2 alpha beta, 2 into 3, 6, the whole square, minus 2 times alpha into beta, 3, the whole square, which equals 4 minus 6 is minus 2, minus 2 square is 4, minus 3 3s are 9, 9 2s are 18, which equals minus 14 is the value. Check it yourself if there is a mistake. This is what I am getting here. So finally what I did here, alpha to the power 4 plus beta to the power 4 is alpha square plus beta square minus 2 alpha beta the whole square, which is nothing but alpha plus beta the whole square minus 2 alpha beta the whole bracket square minus this. So no, remember you must know how to calculate this. Finally if I substitute, I'll be getting this. So immediate, this is more prone to occur in the exam. You must know the manipulation of this one. So finally this is equal to this one. Okay. Any other things? Yeah, one more is last one more thing. Note it down. Let me take one more, 7th one now. 4th, 5th, 6th and 7th one. So find the product of 7th one, alpha minus 1 into beta minus 1 the whole divided by alpha plus 1 into beta plus 1. Do you know the values for this one? See, for the same equation I am solving all these things. I hope you are understanding. Do you know alpha and beta? No, I know only sum and product. Therefore express this given expression, this should be converted in terms of sum of zeros and product of zeros. How do you able to do that? Let's see here, which equals alpha into beta, alpha beta, minus 1 into minus 1 plus 1, minus 1 into beta, minus beta, minus 1 into minus plus 1. Is it right? Are we getting here? 1 minus, just a moment, alpha minus 1 into beta minus 1. Alpha into, just a moment, let me work out once again. Alpha times beta minus 1 minus 1 times beta minus 1, the whole divided by here alpha times beta plus 1 into plus 1 times beta plus 1. Let me check whether we are able to solve this one. Alpha into beta minus alpha minus beta plus 1, the whole divided by alpha into beta plus alpha plus beta plus 1. Here, see here, alpha into beta written as it is, minus you take common, this becomes alpha plus beta plus 1, the whole divided by alpha into beta plus, put into bracket these two and plus 1. Correct? Yes. So we are able to express this into sum of zeros and product of zeros. which equals alpha into beta 3 minus alpha plus beta 2 plus 1 divided by 3 plus 2 plus 1. Okay, so 3 minus 2 is 1, 1 plus 1 is 2, the whole divided by 6, which equals 1 by 3. We got 1 by 3 here. I hope it is correct. So this is how you can find out. Any other thing? Yeah, I think dear students, type 3 I took so many expressions, and especially when the given quadratic polynomial is such that if you are not able to find out the roots alpha and beta by splitting the middle term, in that case how to solve the values of the expressions that involve alpha and beta. So what did we do here? We expressed the given expressions in terms of sum of zeros and product of zeros, substituted the values and got the answers. In order to express the given expressions in terms of sum and product of zeros, a great amount of manipulation is required. Your identities should be good and manipulation ability should be good, which is a skill that can be developed by every student by practice. I hope you understand. I am taking the next type of numerical now. Type 4 numericals. Finding the values of k are unknown with when the relation between zeros and coefficients are given. These numericals are quite prone to come in the exams. Every time you will have 1 or 2 questions like this, finding the value of k. First question will take alpha and beta are the zeros of this equation. Find the value of k if alpha minus beta is given as 1 here. So what do you find out? How do you find out here? Alpha minus beta is given to you as 1 here. What is the significance of this alpha minus beta? Where should I use to find out the value of k here? Or how do you find out the value of k here? Isn't it? So let's see here. Solution. Solution. Given equation f of x equals x square minus 5x plus k. A equals 1, b equals minus 5, c equals k. Sum of zeros. Generally, in order to find the value of k, my suggestion would be you first write the values of sum of zeros and product of zeros, whether those are required or not. You understand? First you write the sum of zeros and product of zeros. There is no harm at all. Absolutely. First you write that one, and then you start thinking what is to be done to find out the value of k based on alpha plus beta and alpha into beta. So I am finding here sum of 0 alpha plus beta equals minus b by a minus of minus 5 by 1, which is plus 5, and alpha into beta equals c by a, which is k divided by 1, which equals k here. So I have got alpha beta as k here. Are you able to understand? Okay. Also given alpha minus beta equals 1. Where should I use this alpha minus beta? Thing is, in order to find the value of k, I must know the value of alpha and beta. The product of the zeros gives me the value of k. But one information I have, alpha plus beta is 5, alpha minus beta is 1. Dear students, you have already understood what is to be done. Are these not simultaneous equations? Solve pair of linear equations, something like pair of linear equations, 2 variables, 2 unknowns. Add or subtract whatever that is required to be done to solve the pair of linear equations and solve alpha and beta, isn't it? So alpha minus beta is given to as 1. Therefore, now alpha plus beta equals 5, alpha minus beta equals 1. By addition of this one, these two will cancel. 2 alpha equals 6. Therefore, alpha equals 6 by 2, which is 3 here. I got the alpha as 3 here. Is it right? Now you substitute the value of alpha in one of the equations, taking alpha plus beta equals 5 and beta equals 5 minus alpha, 5 minus 3, which equals 2 here. Beta equals 2 here. Therefore, alpha equals 3 and beta equals 2 here. With these two values, is it not possible to find the value of k here? Because alpha into beta equals k. Now, alpha into beta equals k. So, 3 into 2 equals k. 6 equals k, implies k equals 6. This is one way of solving this one. Is it right? This is a simple way, but to make it complicated, let me use one more method, but which is the shortest method. Some students, they know already how to find out the value of alpha minus beta. Alpha minus beta equals 1, it is given to you, isn't it? Alpha minus beta is given to you. So what is alpha minus beta the whole square? Alpha minus beta equals 1. Alpha minus beta the whole square also equals 1. Alpha square plus beta square plus 2 times alpha beta minus 2 times alpha beta equals 1. Alpha plus beta square is alpha plus beta the whole square minus 2 alpha beta equals 1. So alpha plus beta the whole square minus 4 times alpha beta equals 1. And therefore, substitute here, alpha plus beta is how much? 5 square minus 4 times k equals 1. So 25 minus 4k equals 1. So 25 minus 1 equals 4k. 24 equals 4k. Therefore, k equals 24 by 4, which equals 6. Is it right? So both the methods you can do. Here I have already explained in my previous numericals. If you know alpha minus beta, and alpha minus beta was the problem there, question there, how to find out alpha minus beta. So here squaring on both the sides and expansion, this is how you can find out. Okay, so note it down. Any one of this method is quite all right. Okay, I'll take up the next numerical. Second problem, fx is given as kx square plus 4x plus 4. Find k if alpha square plus beta square is equal to 24. So based on the given information, if I am able to find out alpha and beta, probably I should be able to find out the value of k. Let's see here, solution for this one. Solution, f of x is given as kx square plus 4x plus 4, a equals k, p equals 4, c equals 4. So as I told you, in such questions, whether it is required or not, first step is find out the sum of zeros and product of zeros, and keep it in terms of k. You may get in terms of k also. First you find sum of zeros and product of zero. Based on the given information, check whether you will be able to find out the value of k. So first step, what I am doing here is sum of zeros, alpha plus beta equals minus b by a minus 4 by k. Yeah, this is minus 4 by k, 1. So I got alpha plus beta in terms of minus 4 by k. Alpha into beta equals c by a. C is 4. A is k. Oh, both are same. So see here, it is c by a and minus b by a. It is minus 4 by k plus 4. There is a difference. It is minus 4 by k and plus 4 by k. Also given alpha square plus beta square. Where is that? Alpha square plus beta square equals 24. This is what is given. How should I make use of this one in order to find out alpha plus beta or whatever it may be? See here, implies you know already what is alpha square plus beta square. Alpha square plus beta square is alpha plus beta the whole square minus 2 times alpha into beta. So here alpha plus beta the whole square minus 2 times alpha beta, which equals 24. Implies what is alpha plus beta? Minus 4 by k. Minus 4 by k the whole square minus 2 times alpha into beta 4 by k equals 24. Sometimes we may get a quadratic equation in this one, and probably you may end up with 2 values for k. Let us see. Implies 16 by k square minus 8 by k equals 24. What is LCM here? LCM, dear students, if it is k square and k, the LCM is not k square into k, it is simply k square. So 16 minus 8k equals 24, implies 16 minus 8k equals 24 k square, implies 24 k square, transpose everything, plus 8k minus 16 equals 0. What is common? 8 is a common. 3k square plus k minus 2 equals 0. Yes, we got the quadratic equation here, and we have to solve this quadratic equation. 3 2s are minus 6. It is to be split into 1 here. I require plus 1. So 3 into 2, minus 3 plus 2. Minus 3 into plus 2, minus 6. Minus 3 plus 2, no. Therefore, plus this one, minus this one. Is it correct now? This is correct. Implies 3k square plus 3k minus 2k minus 2 equals 0. Take common here, 3k, k plus 1 minus 2k plus 1. K plus 1 is common here. Implies k plus 1 equals 0. 3k minus 1 equals 0. So k equals minus 1 and 3k equals 1, implies k equals minus 1 and k equals 1 by 3. So therefore the value of k are minus 1 comma 1 by 3 here. 1 by 3 here. Dear students, one mistake is done here. I'll correct it. I should get 2 by 3 here. What is the mistake we have realized here? See here, common is k plus 1. If I take k plus 1 common, 3k minus 2 is remaining, which I have written as minus 1. So I am changing here minus 2 here. So this will be minus 2. Therefore this equals 2 here, and therefore 2 by 3, and therefore this is 2 by 3. Okay, fine. I think now it is correct. Please note it down. Here we have one more numerical. Fx is given as 2x square plus 5x plus k. Find k if alpha square plus beta square plus alpha into beta equals 21 by 4. As I said earlier, let me find out sum of zeros and product of zeros, whether those are required or not required, and then try to find out how to find the value of k. So solution, fx is given by 2x square plus 5x plus k, a equals 2, b equals 5, c equals k, alpha plus beta equals minus b by a minus 5 by 2, alpha into beta equals c by a, which is k by 2. This is 2 here. Now what to do now? I know alpha plus beta, alpha into beta. So thing is, alpha into beta contains k by 2. So I can find out the value of alpha square plus beta square. Alpha into beta is k by 2. So in this equation, or from this equation, I can find out the value of k here. So let me write down given alpha square plus beta square plus alpha into beta equals 21 by 4. What is the value of alpha square plus beta square? Implies alpha plus beta the whole square minus 2 times alpha plus beta plus alpha plus beta equals 21 by 4. Implies alpha plus beta the whole square minus 2 alpha beta plus alpha beta minus alpha beta equals 21 by 4. Now substitute the values. Alpha plus beta is how much? Minus 5 by 2 the whole bracket square minus alpha into beta k by 2 equals 21 by 4. Let us find out. This is implies 25 by 4 25 by 4 minus k by 2 equals 21 by 4. What I will do here, I'll transpose the right hand to the left hand side and equate it to 0 and take LCM. Implies 25 by 4 minus k by 2 minus 21 by 4 equals 0. Take LCM now. LCM is 4. 4 ones are 2 twos are 4 ones are. So 25 minus 2k minus 21 equals 0. 4 into 0 0. 25 minus 2k minus 21 equals 0. 25 minus 21 4 minus 2k equals 0 implies 2k equals 4 implies k equals 4 by 2 which equals 2 implies k equals 2. Here check it. 25 minus 21 is 4. It is correct. This is the value of this. So how did we make use of the given equation, the given expression? Here we were able to convert the given expression in terms of sum of zeros and product of zeros like this, and finally we substituted sum of zeros and product of zeros in this one and simplified to get the value of k. Note down. I'll take the next sum. I'll take one more example. I think it is the fifth one. I don't know, you remember the serial number. F of t is kt square plus 2t plus 3k plus 2t plus 3k. kt square plus 2t plus 3k. Question is, if the sum of zeros is equal to their product, find the value of k. If sum of zeros equals product of zeros, find k. This is the question. Here k is unknown. F of t means polynomial in variable t here. So let us see here. Solution. F of t is given as kt square plus 2t plus 3k. Okay. From this, a equals k, b equals 2 and c is equal to 3k. Is it correct? Sum of zeros, alpha plus beta equals minus b by a minus 2 by k. 1. Product of zeros, c by a, 3k by k, which is 3 here. This is 2. So given alpha plus beta equals alpha into beta, because sum of zeros is equal to product of zeros. Substitute those values. Minus 2 by k equals 3 here. Therefore minus 2 by 3 equals k. That's all. Meaning k equals minus 2 by 3. Let us check the answer. So it was quite simple, but it appeared to be little difficult, you know. Something, the question is sum of zeros should be equal to product of zeros. So thing is, the first step is you find out sum of zeros, product of zeros, whether required or not. That should be the first step in finding the unknown basically. Okay, so let me take the next problem. Note it down. Here we have one more interesting numerical. If a squared difference of zeros of f of x, x square plus px plus 45 is 144, find the value of p here. Very important, the given is squared difference of zeros. Squared difference of zeros is given to you. First let me write the polynomial for solution. F of x equals x square plus px plus 45, given squared difference of zeros equals 144. Squared difference means squared difference of zeros equals 144. I hope you are able to understand. What are the roots here? Let alpha and beta be the roots here. Okay, therefore implies alpha minus beta the whole square equals 144. This is what it is given. Implies alpha minus beta equals plus or minus under root of 144 plus or minus 12 here. So, implies alpha minus beta is equal to plus or minus 12 here, isn't it? But what is our objective? We have to find the value of p here. As I said earlier, whether it is required or not, you have to find out the sum of zeros and product of zeros as a first step. I could have done that one, but I just wanted to highlight what is the square difference. Therefore, I wrote this one first and tag it one here as 1. Now I find out the sum of zeros and product of zeros. So what is alpha plus beta equals? Alpha plus beta equals minus b by a. A is 1, b is p, minus p divided by 1, which is minus p here. And alpha into beta equals c by a, which is 45 divided by 1, which is 45. Correct? Now can we make use of this one here? Now I know alpha minus beta and alpha plus beta is as minus p. Now what to find out? How to find out? I don't know what is to be done now. Alpha minus beta is given as plus or minus 12 here. And alpha plus beta is minus p here. So I must be able to express alpha minus beta in terms of alpha into beta, or somehow I have to find out the value of alpha into alpha and beta. Then I can substitute here to get the value of p. So let me try one way. What I do here is alpha minus beta is given to me, alpha minus beta, alpha into beta is 45. So by substitution I am getting once again the quadratic equation now. So let me see what is to be done. I'll try here one method. Alpha minus beta equals plus or minus 12. You got it? Alpha minus beta the whole square equals alpha square plus beta square minus 2 alpha beta. Alpha minus beta the whole square equals alpha plus beta the whole square minus 2 alpha beta minus 2 alpha beta. So alpha minus beta equals alpha plus beta the whole square minus 4 times alpha beta. Okay, this is square equals, therefore alpha minus beta equals plus or minus under root of alpha plus beta the whole square minus 4 times alpha beta, isn't it? Let me find out the value of alpha minus beta here by using this. Alpha plus beta is minus p and this. So very interesting. It is becoming complicated, but let us see here. Alpha minus beta, therefore alpha minus beta. Okay, let me keep this as one equation here. First I'll take alpha minus beta as plus 12 and find out the value of p, and next I'll put the alpha minus beta as minus 12 and the value of p will find. I can do one more thing. See here, I can do one more thing to simplify. I'll end this here. Yeah, now I know the value of alpha minus beta, and I know the alpha plus beta value also, because alpha plus beta is minus p. So I should be able to find out from this one. So from here there are two cases. Case 1, alpha minus beta equals plus 12, and case 2, alpha minus beta, case 2, alpha minus beta equals minus 12. There are two values here. Let me check now. So let me solve a little bit this side. Okay, if alpha minus beta is plus 12, put this here in this equation. Alpha minus beta the whole square equals alpha plus beta the whole square minus 4 times alpha beta, minus 12 whole square equals alpha plus beta is minus p the whole square is p square, minus 4 times alpha into beta is 45, and 4 into 45 is nothing but 4 5s are 180 here. So I'll write 180 directly because the space constraint, 180. So 12 4, this is 144 plus 180 equals p square. So how much is this? 180 144 324. Therefore p square equals 324, and therefore p equals plus or minus under root of 324. Therefore p equals plus or minus, check the value, under root of 324. Let me check the value here. Under root of 324, I don't know whether it's a perfect square number or what is that. Let us check. 324, 18. Therefore plus or minus 18. This is case 1. Case 2, alpha minus beta is minus 12. See dear students, even if it is minus 12, I am going to end up with the same answer. Why it is so? Because here alpha minus beta the whole square is involved, isn't it? Whether it is plus 12 or minus 12, whichever value you substitute, finally with this minus 12 or plus 12, if you square it, it is plus 144 only, and therefore the same answer continues. I need not work out case 2 over here. Therefore my final answer for this question will be, therefore p equals plus or minus 18 is the answer for this question. Isn't it very interesting? Isn't it? This is quite interesting, and I hope you have understood how to find out this one. Okay, please note it down. Here I have a very interesting question once again. Fx is given by k square plus 4 times x square plus 13x plus 4k. Question is, find the value of k if one 0 is the reciprocal of the other 0. So let alpha and beta be the zeros here. Solution. Let alpha and beta, or first let me write the equation first. F of x equals k square plus 4 times x square plus 13x plus 4k. So a equals k square plus 4, b equals 13, and c equals 4k. Let alpha and beta be zeros according to question. Okay, beta equals 1 by alpha. Why it is so? If alpha is the 0, then the other 0 is reciprocal of the first 0, and therefore beta equals 1 by alpha I am taking. Therefore, so sum of 0 is alpha plus beta equals alpha plus 1 by alpha equals minus b by a, which is equal to minus 13 divided by k square plus 4. Mark it as 1. I really do not know whether I should make use of this equation to find out the value of alpha. Here alpha is unknown and k is unknown. Definitely two unknowns, one equation, it is not possible to solve. That you must know. All these days you have learnt. If there are two unknowns, you must have two equations. If there are three unknowns, you must have three equations in order to solve those things. So with this I will not be able to solve, because even if I take LCM and all, alpha is unknown, k is unknown. I have only one equation. With one equation, two unknowns, it is not possible to solve. So let me take the product of zeros here. Now the product of zeros, alpha into beta equals alpha into 1 by alpha equals c by a, c by a, or I'll write like this for you in order to, alpha into beta is equal to c by a. Alpha, what is beta? Beta equals 1 by alpha equals c by a. So alpha alpha cancels, 1 equals c by a, implies, I'll write here, what is 1 equals, c is how much? C is 4k divided by a is k square plus 4. Now it is possible, only one equation, one unknown, so definitely it is possible, implies cross multiplication, k square plus 4 equals 4k, implies k square plus 4 minus 4k equals 0. So this is a quadratic equation and I'll solve over here, implies k square minus 4k plus 4 minus 4k plus 4 equals 0. So by splitting the middle term, is it possible? I should get 4 here, and if I split the middle term, minus 2 into minus 2 equals minus 4. Yeah, it is possible. Minus 2 minus 2, minus 2 into minus 2 is plus 4. Therefore, it is possible. Implies k square minus 2k plus 4 equals 0, implies k common, k minus 2 minus 2 common, k minus 2 equals 0, k minus 2 into k minus 2 equals 0, implies k minus 2 equals 0, k minus 2 equals 0, implies k equals 2, k equals 2. Therefore, the value of k equals 2. I hope you have understood how to solve these numericals. So, dear students, with respect to quadratic polynomial, I categorized the numericals in terms of type 1, type 2, type 3, type 4 to make it easier for you to understand the different kinds of numericals. Here we have completed quadratic polynomial section. In my next lecture, I'll take cubic polynomial. In that one, let us establish the relationship between the zeros and coefficients and solve some numericals, and finally we'll go for division algorithm. So see you in the next lecture. Thank you.